Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you're watching live or you're watching the recording, I just appreciate you tuning in and watching. This is the very first day of the semester. Good afternoon. Good afternoon. See the chat in there. Good afternoon, everybody. Welcome to our first live stream of the semester, right? It's a new semester. It's always exciting to get started on something new. And we are, working through the Introduction to Programming and Logic this semester. And in Introduction to Programming and Logic, we use Python. Good afternoon. Good afternoon. And as such, as we're using Python, we'll talk more about why we use Python in this course in just a little bit, right? But as we're kind of getting started here, just a few kind of ground things based on, what we do in these live classes. I like to have these live classes. I like people to come on. I like people to be able to ask questions. I like to be able to interact with you all, if you are able, right? And I realize that not everybody's able to attend these live sessions, so I record them. And they're available afterwards, right? I save them on the YouTube channel. I also make an alternate recording for, like some of the high school students, for example, can't necessarily get to everything on YouTube on their Chromebooks for school. So I like to, I like to have a second recording that I can upload that is available for everybody to watch as well. So I think that's a good way to do it. I do it on YouTube typically because I think, one, it's a place where people go to learn things, right? I believe the statistic was 80% of people, when they're getting ready to learn something new, they go to YouTube to try to learn something first. And so I figured, if people are going to YouTube to try to learn stuff anyway, I may as well kind of cut them off, on their way and get ahead of it and, just use YouTube myself. I also think it's a little more kind of lower stakes, right? I can see that, people have already wished me a good afternoon, and I really appreciate that. And good afternoon to you all as well. I can see the things that people are chatting with me. I can take questions as they arise. And we can kind of do a little bit of interaction without you having to raise your hand and speak out in front of the class. And I think, that's pretty beneficial, right? Because, sometimes we get a little nervous, get a little anxious to do that. But just one more thing here about these live streams before we get started on them, and that is that I like them to be, relatively short as far as live streams go. I don't like to go over an hour, right? So if you were in class, you might come to class for 2 hours, maybe even 3 hours or 4 hours a week. But I don't like these live streams to really last much more than an hour. Sometimes if we get involved in doing a good demonstration or something, they might last a little bit longer. But I think an hour is a good sweet spot. I think that's when, everybody's starting to get bored and stuff as well. So there's that. But as I mentioned in the course, we are, as we're starting the material, we're actually doing the material for the next module. So material that we're covering today is from Module 1. And Module 1 doesn't officially start until tomorrow. Right, the first couple of days here is just for, kind of getting acclimated, doing the orientation activities, kind of making sure that everybody can get into the course and get around the course okay. You want to make sure you have your EVA completed, your introductory discussion board, and your orientation quiz completed, ideally by end of day today, right? Because that's when I have all those things being due. And then tomorrow we'll officially start Module 1, and my live class for Module 1 is today, before that module starts. So, if you have any questions about any of the orientation material, just let me know, and we can work that out. Although I think it's relatively cut and dry, especially if you've had classes with me before, which I think many of you have. I know there are some new names that I've seen in the list this time, so I'm excited to welcome you all. But I know many of you have had classes with me before, and so you kind of understand how I do things and all that kind of fun stuff, so we can just kind of get rolling on. So we are talking about Python today. We're introducing Python, and I'm going to put a question in the chat here. Trying to implement this poll feature this time around. I was just wondering if anybody who was with me today had ever used any Python before. Python's a pretty common programming language, so I imagine that a lot of people, maybe have at least tried it out. I know if you took CTI 110 last fall, we did a little bit of Python in that class, so if you took that class, your answer should be yes. Just if you've ever written any kind of program or any kind of script in Python before. Good. So it looks like everybody who's here with me today has had some Python experience, which is pretty cool. Even a little bit is a good amount of Python experience for this course, because we do start at the very beginning, right? So, even if you, had a little bit of experience, just got a little taste, like if the only taste of Python you ever had was CTI 110 last fall, then you're fine. If you've never had any Python before, you're fine. We start from the very beginning in this course. And we also frame it in relation to the idea of programming in general, and using Python as sort of this jumping off point to kind of get you into programming in general, because as you get a better understanding of the kind of structures and language and thought process that you have to do to get into this stuff, you can transfer your skills from Python to other programming languages. And so, Python's just a really good language to kind of get started with as we're approaching this here. And, as I kind of like to do, I like to start things off by defining some terms, right? And I think that's pretty important, is to define some terms and allow us to kind of understand what we're doing here. And so I think the first big thing that we want to define is that, well, we said we're going to be writing programs. Just what exactly is a program? And so when we're looking at a program is just a sequence of instructions that specifies how to perform a computation. And so that seems kind of like a complex idea, right? This sequence of instructions that specifies how to perform a computation. But one of the things that I like to do is I like to kind of take these definitions that we have and these ideas that we have surrounding the complexities of computer science and programming and all this kind of stuff, and I like to break them down a little bit, right? So when we talk about a sequence of instructions here, we can talk about what that means. And when we talk about a computation, we should probably take some time to talk about what a computation is, because, computer, right? Our word computer, or what, comes from the same roots as the idea of a computation. And typically when we think about computations in general, we're thinking about computations in relation to like math, right? So, we think about these, when we think about computations, we think about these big mathematical equations that are, really complex or hard, or, maybe has letters in places of numbers somewhere. But when we're talking about computations in this sort of sense, we're really talking about computations in a relation to an algorithm. And we'll kind of talk more about what algorithms are as we progress. An algorithm isn't as serious as it seems. But a computation might be something mathematical, right? We'll do a lot of programs that utilize mathematical computations to perform a certain task. Right, so, we got some complex examples here, like solving a system of equations or finding the roots of a polynomial, but even something just as simple as like, oh, I need a program that'll find the length of the hypotenuse of a right triangle, Or I need a program that'll find me the area of a circle. These much more simple computations. Even something like just simple addition, right? Like that's a programmatic based computation. But, even more than the idea of mathematical computations, we also have symbolic computations. And symbolic computations are alphanumeric. They involve, different steps. And they're these things that are kind of the other parts of programming, right? Like we use programs to create and edit images, for example. And so there's some computation going on in the background that works with creating and editing that image, right? And so it does break down to math typically, right? Because when we think about it, and it's one of the things that we'll talk about as we kind of progress in the course, everything kind of goes back to binary and the idea of binary computations. And we talk about binary in terms of math to some degree, right? Like we talk about a mathematician by the name of Boole, whose whole idea was basically any mathematical equation can be solved by implementing a series of basically true-false questions, right? And that's where we get the idea of a Boolean operator from, something that can either be true or false. And if we kind of break it down to its smallest parts, we can kind of look at things in terms of whether or not they're true or they're false, right? So math in programming really isn't that challenging, right? One of the things that people ask a lot is, do I need to know a lot of math to be a programmer? And, to some degree you do, right? If you're going to be performing something that's more complex, right? Like if you're going to be, for example, creating a simulation that follows the arc of a certain thing, right? Like we see that like ballistics a lot of times, right? Like if you, or whatever, right? You want to be able to see, if something is going this velocity for this distance, how much will it have fallen by the effect of gravity impacting it, right? And so that's a simulation that we can make in a program. And that's a reasonably complex mathematical computation. But as we're getting started, especially, like we're not really doing anything like that, right? Like if we can basically add, that's about all it takes to get our foot in the door to be able to program. So if you can add, you can program. Right, and so we have this other thing that we probably need to define here, right? We've said that, it's a sequence of instructions to perform a computation. We said that a computation can be mathematical, it can be graphical, it can be alphanumeric, right? We could be searching through text and replacing things in a document or playing a video or something like that. But there's that other word there, that sequence of instructions, and we haven't really touched on what an instruction is. And so when we talk about an instruction, for our purposes, an instruction is a single line of code. And this is where we kind of get into the idea that I discuss in a lot of classes that, we think that our computers are really super smart because, we can turn them on and they can do whatever we want them to do. But they're actually pretty dumb, right? They only do what we tell them to do. They only execute our instructions. Right, so a line of code is basically an instruction to my computer, who's not very smart, to tell it what to do. Right, and as we get into programming, all the different languages look differently, right? My spring semester is typically a more challenging semester because it is the semester when I am programming in the most programming languages at a given time. This spring in particular, I am programming in Python, in Java, and in a special version of JavaScript called React.js for modern front-end development. But one of the things that you see as you start to work in different programming languages and things of this nature is that even though they look really different, there are some things that are consistent across every single programming language in existence. And I have those listed for you here. Input, output, math, conditional execution, and repetition. And if you noticed, for those of you who were in the fall CTI 110, we've added one here, right? Typically in the CTI 110, I talk about input, output, math, and repetition, I believe, on their own. Or maybe I included conditionals. That was a long time ago. But input, output, math, conditional execution, and repetition. These are the things that every programming language can do, right? Like, it can take data from a source, whether it be your keyboard, another file, a network, some other device. It can show you the results of the processed data on the screen, or save it to a file, or send it somewhere, right? So it can give you that output. It can perform basic mathematic operations, which is kind of where we go in this very first module, is just kind of using Python to do some basic mathematic operations for us. Conditional execution are conditionals. Those are if statements if you've done a lot of programming before. These allow our computers basically to make decisions. It allows it to check for certain conditions and run the appropriate code. And then finally, repetition, which is the ability to perform some action repeatedly. And in this course, we introduce two ideas of repetition, which is our loop, which is kind of our simple repetition. And we also introduce the idea of... Oh, why have I lost the word? That's the thing about doing things live. Sometimes you lose the word. Oh, goodness. Recursion. Recursion is the word I'm looking for. There it is. Recursion. So we introduced the idea of recursion along with loops for repetition. And we'll talk more about that when we get there. So an instruction is just a line of code, and these instructions can look very different depending on what's going on here. But at the end of the day, most programming languages are similar. Most programming languages have all of these things that can be utilized. So what exactly is Python? So Python's a really good programming language. It's a programming language that I like to use to kind of teach this introduction to programming sort of class. I remember when I took my first undergraduate class that involved programming at the University of North Carolina, we were taught on a programming language called Turing. Turing, named after Alan Turing. Many of you may be familiar with him, especially those of you who took the CTI 110 last fall. But it was essentially what they call a teaching language. Right, one of the old school ways to kind of work with programming is to work a lot in the early days with writing what they call pseudocode, which is basically fake code to kind of help you understand logic, and working in teaching languages like Turing to have a means of teaching you without kind of overwhelming you with a full system. And that was really, that was all well and good, right? But it wasn't useful to me as a student, right? Because once I left that class, no businesses were using Turing to write code. It was a teaching language, right? So the things that I learned specifically about that language immediately after, passing that class meant nothing. And so I like to start with Python because Python's a high-level, programming language. When we talk about the level of programming languages, high level or low level, the higher level of programming languages, the closer it is to a language that we speak, say English. So you have your high level programming languages like Python and Java and C++ and all this kind of stuff. And then when you get into your low level programming languages, these are programming languages that are more akin to machine code. And these would be things like assembly, right? So if you're not familiar with assembly, you can take a few minutes to look it up just to see what it looks like. Yep, got a note here. Had this class in 2006, and it was Visual Basic then. Yes, it was. It would have been Visual Basic, which is also, it's not as useful as it was. I think there are still like maybe a handful of companies using VB script. One of the things I really liked Visual Basic for was just the ease of creating GUIs to go along with your program, because that was super easy in there. But yeah, at least at this institution, we've, to my knowledge, always used like good languages. It's been done in VB script. I know it was done for a little while in C++ and now in Python, which I think, or I hope, like C++ is a really heady programming language to try to get into if you've never done much programming before. But I think Python's really friendly. And that's one of the reasons why I like to use it. It's dynamically typed, which we have here on our screen. Is that something that's dynamically typed is different from, say, Java or C++, where when I create a variable in Java or create a variable in C++, I have to tell my computer what type of data it is. Whether it's a string or a integer or a floating point number or a Boolean flag variable or what have you, right? I have to tell my computer this variable is holding this kind of data. Python, I don't have to worry about that. It's dynamic. It can read my data and it can understand it. So that's nice and friendly, right? It takes something away from us that we don't necessarily need to do as we're getting started. It's batteries included, so a lot of distributions include many modules or many libraries on top of it, which means we won't have to worry about like going and downloading particular modules for what we do, right? We stay pretty simple for the code that we write in this class anyway, so it's not a huge deal. But, a lot of things are already included into it. And it's open source and community driven. I like to, one of the things that I sometimes will like to do, especially in the CTI 110 class, is just show you the source code for Python, right? There, basically every programming language that you know of was built using some other programming language, right? So it basically just kind of has fathers or parents that it comes from. Right, so when you look at Python, you see a lot of C, C++ that's been built in there, that's been written in there to write Python, to take code that you could write in C++ and just make it a little friendlier, make it a lot easier for us to get started with. And this was all created by Dutch programmer Guido van Rossum, which, not super, like, I'm not going to test you on the fact that Guido van Rossum invented Python, but it's a good thing to know. And we've kind of hit on a lot of these already, so we can kind of roll through this. Python is one of the most widely used programming languages in the world. When I was kind of redesigning the programming and web development program here at CCC, one of the things that I said I wanted to do is I wanted to have useful programming languages that a lot of people are using to put into the program. And when I looked at the most widely used programming languages in the world, the three that were on top were Python, Java and JavaScript in no particular order, right? It might have been JavaScript, Python, and then Java, if I remember correctly. If we expand out into like the top five, you got SQL, you got C++, a few other languages, but if we want to kind of get good at some of the stuff, we can kind of just focus on a couple, and everything else comes with just kind of learning the basics, right? Like if I learn how to employ logic, if I learn how to think like a programmer, and if I learn how to do all this kind of stuff in Python and or Java, then switching into C++ or Ruby or whatever else, right, isn't as big of a deal. Because I know, like, oh, hey, I need to use a loop to be able to execute this. I might not know exactly what a loop looks like in, say, Rust, but I know that I need a loop, and I can go look up what a loop is in that language. Once you have those skills, right? Like they were asking me, about a year or so ago, they said, we're getting this pressure from the state about Swift and Swift programming. What can you tell us about it? And I was just like, well, let me. It's not incredibly useful for us because its only real purpose is to make iOS apps, but let me play with it a little bit. And within just a couple minutes, right, I was up and writing code in it, even though I'd never really written much Swift before, because I had a good understanding of the basics and the logic, and anything I didn't know I could easily kind of look up and figure out, because I knew of the structure of how programming in general works. And so that's going to be a big goal of ours, is just to kind of have this understanding of how programming in general works, and then we can expand out with it. It's been around since 1991, so it's been tried and true. It's been tested, right? And I'm not sure a lot of people even know that Python has been around that long. That means that Python is older than JavaScript. It's just a little bit younger than Java. Right, actually, I think Python and Java came out around the same time. And I think just since it kind of boomed within the last, 5 to 10 years or so, people think it's a much younger language, but it's actually been around for, over 30 years now, which is pretty cool, to kind of think about that. It's been around that long. It's been utilized. So we know it's good, and a lot of people are using it. And it gives you the ability to focus on your logic, which is good for, a course called Introduction to Programming and Logic, without having to focus a whole lot on syntax, right? Because the syntax is pretty easy. And it is called Python because Guido van Rossum was a big fan of Monty Python's Flying Circus. Again, just another little fun fact thrown in there. So as we're running Python, for simplicity's sake, we're going to be using an online IDE. And IDE stands for Integrated Development Environment. And this integrated development environment is called Replit, or REPL.IT. REPL is a common acronym that we use in programming as well. It's a good thing that we want for our IDEs. REPL, R-E-P-L, stands for Read, Evaluate, Print, and Loop. So it just kind of goes back to those 5 things that we talked about earlier and just kind of puts them down into 4. Because it's kind of combining the... Or it's not considering input, reading, evaluating, printing, and looping. Or I guess reading is input. Which one's it leaving out? Math. Math is the one that it's leaving out. It's kind of taking math and combining it in evaluate with conditionals, right? Because that's evaluation. There are instructions in the course on how you can download and run the standard Python IDE, which is called Python Idle. But I would actually recommend you not doing that just because it's something else that you'd have to kind of keep up with. Right? I really like using the online IDE, one, because it's just kind of easy to spin up and run. And two, because like if you are, say, at school in the library working on something, and then you decide, oh, it's time to go home, you go home, it's still there, right? You don't have to save it. It's all cloud-based, and it's all good. Right? And for those of you who are CCP, it works on your Chromebooks, whereas, you couldn't get that with something that you have to download and install there, so that's good. Let's take a moment here and let's just switch over to Replit just so we can kind of see it and see how it works here. Way too many windows open. Where is my Replit window here? I know I had one open. There it is. My Replit window. Now let's switch over to full screen here so you all can see this a little bit better. This is right after you log in. You should see a home screen that looks like this or looks similar to this. And when it comes to creating a new Replit, right, it gives you a lot of options. There's a big button up here that says create. There's a little plus button over here in the upper right-hand corner that's to create a new REPL. And there's this create button here in the middle. And you can use any of those. They all do the same thing. Right? They will all pop up the create REPL option. So we'll just click this one here. I have the programming languages that I use regularly in my Replit here, or in my favorites in my REPL here. Python, HTML, CSS, JavaScript, and then a blank REPL, which I can't remember what that one is. Some kind of template, right? But when you get yours, it won't have favorites there if you've never used it before. If you have used it before, you might have some favorites there. So if you don't have any favorites, you're going to want to just type in Python in that template box there. It'll give you some different options. Python for data science, Python Discord bot, Python with Turtle, P5JS with Python, all this kind of stuff. This is some fun, more advanced stuff that you might want to try at some point. But for the purposes of this course, all we want is just a plain old Python. Just plain old Python, nothing else in there with it. We're just keeping it simple as we're getting started. And then you're going to give it a name. It gives you kind of a random name by default. It's given me austere, dreary strings. I don't necessarily want that. I'll give it some other name like my first program, and then I'll put Sp23 on here because I do this demonstration all the time, and I have about 50 my first Python programs on here. And then we can click to create the REPL, and we get this environment. Right? We can see we have a code window here in the middle where we can write our code. And we have a console window here on the right-hand side where it'll run our code. Now, when you're turning in assignments and you're using this, what I want the URL to your Replit up here at the top. Right? You'll see when I highlight mine, it shows up in green up here at the top. I can zoom into that if my zoom will work. There we go. I want the URL from the URL bar. And that gives me the ability to, when I click it, it'll take me to there. Right? I can look at it, I can run it, I can see the code you wrote, I can run your code to see if it works. And all that kind of fun stuff so we can do our thing with it. And so we type code in this middle window here, and when we run it by clicking the run button, it'll execute over here. So before we wrap up today, let's do a little bit of code, shall we? The first thing that I have that I want to see in everybody's programs is a shebang line. It is a shebang line. So shebang is a portmanteau, or it's basically two words kind of squished together, of hash and bang. And the shebang doesn't really do anything in our program specifically, right? One of the things that a shebang does is it kind of looks for the environment on the computer as your script is ran. So if you have Python 3 on your computer installed in the default directory, and you have a Python file that has this line as the first line in it, you can actually double-click that Python file and it'll automatically run. It's just a best practice for creating things in Python. So it's just something that I'd like to see in all of your programs. As we kind of go forward is this shebang line. So we can write one in my replit here. And you know what? Before I do that, I kind of got ahead of myself here, because I usually demonstrate like what the console can do, right? For most of our purposes, we're going to be using the console for output, but you can also kind of do things directly in the console. Like if I wanted to run some just simple equations in the console, I can, for example, shoot. I clicked the wrong button. That was fun. I meant to hit 4 and I hit F4. So 12 plus 43. And it'll evaluate it, right? Like we can enter simple equations into our console and it will evaluate them. 10 minus 8. 15 times 32, 480. 45 divided by 15, 3. Right, so our console has some use to us outside of just being somewhere where things are printed. And if you get a lot of stuff in your console, this little trash can here on the right-hand side will clear that out for you. So let's start out by writing our shebang, and that's hash bang, or hash exclamation point, /usr /bin/env space Python 3. And so that's our shebang. And it's something I'd like to see in all of your programming, in all of your Python programs that you're writing going forward. Just have this line of code at the top, right? If you were in my CTI 110 in the fall, we practiced this best practice there as well, so it shouldn't be something new to you. But if you're new to this class or new to Python here, just make sure you include it. Now, normally, one of the first assignments that you would get in a programming class would be a hello world. It's just kind of all you're doing is printing out the terms hello world to the console. But in Python, it's a little too easy. So I have a little more challenging first assignment here. But we'll write a hello world right now just to show you how simple it is, right? And why we wouldn't want to do a hello world as a first assignment in this course. It's just a little too easy. Right, so whenever I want something to go out to the console, right, when we think about REPL, read, evaluate, print, and loop, or we think about our, those 5 things from earlier, input, output, conditionals, repetition, math. To be able to print or get output, we need a statement that's going to send that to our console. And in Python, that is the print statement. So we start out by typing the term print. And then after that, we put a pair of parentheses. And so the parentheses here dictate that print is a function. And a function is just a block of code that does a specific thing. All right, so whatever I put in between these parentheses, my program is going to print out. So if I were to put a string in between these parentheses, and in any kind of programming language, we denote a string by utilizing quotes, because having the quotes there makes a string of text different from what might be a program command, right? That's how we distinguish our strings from our program commands. I can type in whatever I want, like hello world, and then I'm done. I have written a hello world in Python. And it's just as simple as that, right? It's one singular line of code. And so if we run this, we see we get hello world over here in our console. That's our output. Right, so that's about as simple of a program as you can get when it comes to, writing some Python. We can also do basic math in our print statements. Right, so for example, if I wanted to see the results of a mathematical equation, I can print something like 5 times 5. All right, so I left our hello world statement on here just to point out that our code reads from top to bottom. So it's going to execute each instruction that it's given from top to bottom. So it's going to print hello world, and then it's going to print the result of 5 times 5, which if we see that in our output, that is 25. And I can do that with basically whatever kind of equation I want. We can run an addition equation in here, 12 plus 8, that'll give us 20. We can do a little subtraction here. 45 minus 25, that's also 20. Let's make it 35 to be different. Or our simple thing like division, print 50 divided by 10 to give us 5. Right, and it's going to evaluate all of these from top to bottom. So hello world, 25, 20, 10, 5. Now we do see that our division problem doesn't give us 5. It gives us 5.0. And that's because of that stuff that's going on the back end that I was talking about earlier. Right? Python's smart enough to know that when you're doing a division problem, you might have a remainder. You might have a decimal remainder, floating point number. So Python doesn't care about data types, but the languages that Python is built on, C, C++, that sort of thing, they do care. So if you want to end up with a actual thing that you can work with here that might have a floating point number, then you'd want to use floats as a data type on the back end in C and C++. So it's automatically converting these numbers into a number that has a floating point. Now we can work around that by doing some typecasting of our own, right? And basically telling Python to turn this back into an integer. right? So for example, if I took and I wrapped an integer typecast, which is just an int function here, so we can see that if we zoom in on this, I've included int for integer and then another set of parentheses here that I've wrapped around 50 divided by 10. It's going to evaluate from the inside out. So it's going to give me that. It's going to turn it into an integer, and it's going to print it out. And so if we do that, then now we see that instead of 5.0, we just have 5. Right? And typecasting, we're going to want to, we're going to get really used to typecasting different things as we kind of progress as well, especially when we get to inputs. We'll have to do some work with typecasting there as well. Some other equations that we might, or some other operators rather, that we might want to know are exponents. So if I use 2, asterisks, that will give me an exponent notation. So if I say, okay, let's print the result of 4 asterisk asterisk 4. So we see here that 1 asterisk is multiply. 2 asterisks are exponents. So this is like saying 4 raised to the power of 4. So that's 4 times 4 is 16, times 4 is blah, 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 times 4 is blah, 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 times 4 is blah, blah, blah. It gives us 256 as our output there. One that we don't really talk about as much is the 2 slashes. This is for floor division, so it rounds down. So if I did something like 35 divided by 3, that is floor division. So that's going to round down to the closest whole number, regardless of what that decimal number is, right? If we looked at, for example, just print 35 divided by 3, we see the floating point number that we get there is 11.6 and continuing. If we use floor division, it's going to round down to the closest whole number. Now, to contrast that, if we were to take that and typecast it, it won't let me typecast it in this instance. I don't believe, or we could see how it behaves there, because that's something that I always forget. If we print the typecasted version, the integer typecasted version of 35 divided by 3, we get 11 as well. So it's basically doing the same thing. It's rounding down. So our floor division there is another option in terms of what we're doing here with our typecasting. Because I believe if I do this here as well, 50 divided by 10, yeah, it gives me the whole number also. So these are just 2 different ways to do things. And I bring this up, right, because it does introduce a concept here to our programming that is kind of important, right? And that's the idea that things can be done multiple different ways, right? So what we're kind of trying to figure out here as we're getting started is, what's the best way for me as an individual to be able to do it? So if the idea of integer typecasting 5 divided by 10 makes sense to you, that's what you want to do. If it makes better sense to you to do the floor division, that's what you want to do. Right? We're trying to, figure out things that are good for ourselves, that make sense to us, especially as we're getting started. One of the things that I say a lot as we're learning to program is that first we just want it to work. First we just want to make it. And if we can get it to work, then we can start to work on making it better. And so I think that's pretty crucial. And so all of these are just simple little mathematical equations. We can get even more complex with these mathematical equations. So for example, if I wanted to print the result of 35 floor division 4 times 3 minus 2, or 3 minus 2. I mean, that's a little, well, you know what, that's a little goofy for our example here. So let's say times 3 times 2. Right, because what I want to get to here is the idea of order of operations and PEMDAS, and how different numbers can be different based on how you have them formatted in your print statement for evaluation. So when everything is given equal priority, we have floor division, we have multiplication, and we have multiplication again, right? If you remember back to math classes, you might remember something called PEMDAS. And that's how we dictate our order of operations. And we have parentheses, we have exponents, we have multiplication and division, which are technically on the same level. And we have addition and subtraction that are technically on the same level. So if we're doing multiplication and division operations, we're just doing them from left to right, which is the only type of operation that we have here. So we're just going to do it from left to right. So it's going to do this first, do 35 floor division 4, times that by 3, times that by 2. And we end up with 48. And one of the good things that we can do is that, you know, if we start with simple problems and then branch them out and make them more complex, which is something that we'll talk about as we progress. Yep, please excuse my dear Aunt Sally. PEMDAS. Correct. That old gag. But we can look here at our 48. We can kind of go back with it. And we can say, okay, 48 divided by 2, that's 24. Divided by 3, that's 12. If we look at our floor division here, or divide, no, wait, what did I say? It's getting late in the day. 48 divided by 2 is 24. Divided by 3 is not 12. Divided by 3 is, math brain work. 24 divided by 3 is 8. 8. So we end up with 8. And so if we say, well, 8 times 4, gives us 32, but it gives us that because we did floor division. So what we'd have gotten at this part would be 32 and some change. Or would be the result would be 8 and some change. Right here, but we round it down to just 8 times 3 times 2, which gets us 48. But as we start to put parentheses around this, we can see that, you know, it's going to impact the way that it reads things. Right, so we put parentheses around that, and now our result is 4. Because instead of 35 floor division 4, it's 35 floor division 4 times 3, which is 12. And 12 can only go into 35 twice with a bit of a remainder, so it's 2 and change. We round that down, it's just 2. 2 times 2, that's 4. That's what it gives us. And so on the opposite side of floor division, where it doesn't give us our remainder, we do have one more operator here, and that is called the modulo. And the modulo is a new one. The modulo helps you find the modulus, which is actually the remainder that you get after a division problem. So if I were to look at, maybe we can even use these same numbers here. If we look at printing 35 floor division 12, and then printing 35 modulo 12, and modulo here is represented by our percent symbol. For this one, we would get the whole number. And for this one, we would get the remainder. So a whole number of 2, remainder 11. So 2 times 12 is 24. If we do 35 times 24, that's 11. That's our remainder. So that shows us why we get that where we have that there. That's both sides to that equation. And then again, just to have all 3 of them there, if I wanted to do a singular division symbol and say print 35 divided by 12, we see 2 and some change, 2.916 and continuing. And so it's all different ways to represent our number, which is pretty cool. And there is a little trick that is involved in a little bit of mathematics, right? Like all you need for your lab for this module is the stuff we talked about here. And there's a little trick that, some people might know and some people might not know, that maybe I can kind of reveal for the benefit of those of you who choose to watch this far into the video, because we've almost gone a full hour here. And that's how to get a square root without using a square root function. In future modules, we'll talk about libraries. We'll talk about how we can use the math library in Python to do some things for us. One of those things that's in that library is square root, but we actually don't need that, right? Because we have exponents. And so if I raise something to the power of half, that's the same thing as doing square root, right? So for example, if I were to take print 16 to the power of 0.5, that's the same thing as doing the square root of 16, which is going to give me 4 here on the end. 4.0. And if I wanted just a solid 4, again, I could typecast. And by typecasting, I get just a plain old 4. And so with that, plus using your noodle, you can do basically everything there is to do that you need to do for our lab this week. That's due next Thursday, right? Remember, we're a week ahead. What's due today is the intro orientation module stuff. And so with that, I'd like to just kind of close our session today with just a little bit of talk about debugging here. Because this is one of our tougher things that we kind of deal with, is this idea of debugging, because we all want to be good at everything right away, and it's unlikely that we will be. Right, and so what we're kind of introducing right now is just the concept of debugging in general. The fact that programmers make mistakes, right? You'll probably make a lot of them over the course of the semester while you're learning. That's natural. And I know I've had times where I've been really struggling with a bug or really struggling trying to figure something out. And it's just like, oh, I uppercased where I should have lowercased, or there was a semicolon that needed to go there, or there was a colon that needed to go there, or my tab alignment is off, just something really trivial and silly. And it might make you mad, it might make you sad, it might embarrass you. One of the big things that we want to kind of work through here as we're kind of getting started is the idea of being persistent and getting things debugged yourself. Right? You know, one of the things I say a lot as we kind of enter in to programming is that if you get out and you're programming in the real world, nobody's going to tell you every line of code to write. If they could tell you every line of code to write, they wouldn't need you to write it. So it's about solving the problems for yourself and figuring out your way to solve those problems. And sometimes that might leave you in a little bit of a hole that you have to kind of figure things out. And one of the best things that you can do, especially at this point, is to try for a little while to figure things out. Now, I don't want you banging your head against the wall like all afternoon trying to figure something out where, you know, you probably just need a little help figuring it out. But I do encourage you all, if you want to get good at programming or you want to get better at programming, getting comfortable with kind of struggling a little bit and, you know, not necessarily knowing and trying to figure it out on your own is ultimately going to make you a stronger programmer as far as all that goes. So as we wrap up here, we'll open up for questions. I'm just going to I'm trying out some of the other YouTube features this time, so I'm going to open up a Q&A here just in case anybody has any questions as we kind of wrap up. So you can pop some questions in there. For those of you that are here, you know, as we're kind of waiting to see if anybody has any questions, I just want to thank you for coming today. Thank you for joining me. I hope you can join as many as possible, right? Remember that, you know, attendance is not mandatory, but I do think it helps. A little about the discussion board. Sure, you know what, let me get I do have a different slideshow for that. So let me grab that to kind of help you out a little bit. Because the discussion boards, at least for the first few modules, are about logic. And they're about trying to figure things out logically. And so the goal of the first few modules of discussion boards, it's only in like the first 3 or 4 modules that we have them like this. But the idea is that you're trying to think like a computer. And so in doing so, I'm presenting to you, at least this week, the idea of propositional logic. And so it does seem like it's more challenging than it actually is. Because all we're really asking for is a statement that is true or false. Right? A proposition is a statement that is unambiguous. It is concrete. So it can either be true or false, never both, never ambiguous. Right? If I say this is a box, and I hold up a cardboard box, that's a proposition. Because that's a definitively true statement. You can look at that box, you see the box, you say that's a proposition, that's a box, that's true. Proposition. If I hold up a pair of headphones and I say this is a box, that's a proposition. It's false, but it's still a proposition, right? It's a definitive statement. If I hold up a box and I say something really cool is in this box, you can't verify that. That's neither true nor false. You don't know, right? It's an ambiguous statement. So you don't know if there's something in that box or not. And then if there was something in that box, whether or not it's cool is kind of a, questionable statement. Right? So that's not a proposition because there's ambiguity there. When our computers are thinking and when our computers are using logic, our computers are dealing in matters of propositions. They're dealing in matters of things being either true or false. So if we try to get our computers to evaluate something that's in a gray area, it's not going to have a good time. Another thing is like a question, right? Which would be like, is this a pencil? Well, that's not a concrete statement, right? It's a question. So based on that alone, it's not a proposition. Right? So when we're thinking about propositions, we're thinking about just something that is either true or false. Gamblers, if you're familiar with a prop bet, that's a proposition bet, right? That's a bet that's based on a proposition, something that can either happen or not happen during an event. Like you get an over-under on how long it takes for the national anthem to be sung, right? So we have some examples here. These are all declarative examples, which are propositions, right? Washington, D.C. is the capital of the United States of America. That's a proposition. And that's also a true statement. But conversely, number 2 here, that's also a proposition, even though that's false. Right? Toronto is not the capital of Canada. Ottawa is the capital of Canada. Toronto is just the largest city. But this is a concrete statement. This is a definitive statement somebody is making. Whether it's right or wrong, it's still a proposition. Right? Which we see that mirrored there in our little addition statements. 1 + 1 = 2. That's true, and it's declarative. It's a proposition. 2 + 2 = 3. That's not true, but it's still declarative because we can determine that it's either true or false. And so it is not a proposition. So propositions 1 and 3 are true. Propositions 2 and 4 are false. But regardless, they're all 4 propositions. And so that's all I'm really trying to get at here in that first module. Discussion board logic piece is just look at some statements and evaluate whether or not you think they can be declaratively stated as either true or false. If they can, they're propositions. If they can't, there's something else. Does that help clear things up? Is a command a proposition? When you say command, would you mean something like open a door? Like open the door? Wait a couple seconds here for the lag to come up. Yes. Okay. So no. A command is not a proposition because it cannot, can't be, it's not declarative, right? I could say open the door, and that's me telling somebody else to do something. Whether it's not a statement of fact, so it's not true or false. It's ambiguous. It's a direction. So in that sort of way, I can't say that a command is a proposition. If I were to say something like, the door is open, on the other hand, that would be a proposition. So does that help clear up the idea of propositions for everybody? I hope so. Excellent, excellent, excellent. Thank you. Anything else as we kind of wrap up today? Yeah, let me look at the list. Yes, you're just using the basic print statements with math to get the answers to the lab prompts. Yeah, so you're basically just using Python as a glorified calculator. Yeah, I got to get used to this YouTube interface. I'm trying it out this semester. But yes, yeah, you're basically just using Python as a glorified calculator and just using print statements with the operators to get the answers to the problems. Excellent, excellent, excellent. All right, I think with that we'll go ahead and wrap up today. If you think of any more questions, please send me a Teams message or an email, and we'll get them answered up for you. Thank you, thank you. Enjoyed doing it. That's all that I have for you for today. We'll do it again next week. If you have any questions, let me know. Email, Teams, whatever you need to do. Thanks for coming, and we'll see you next week.